Alright guys, let's get busy talking about the menstrual cycle. Let's go ahead and orient ourselves to the diagram we're going to be using. So here at the top we have our phases, and the phases are going to be with respect to which organ we are talking about, either the ovary or the uterus, but it is going to be the same cycle. So here in the bottom we have our ovary, which is consisting of the follicular and the luteal phase, and then up top we have our uterine cycle, which is with respect to the menstrual, proliferative, and secretory phases of the cycle. Next we have our egg, and the egg is a simplification here. We will talk about all the names of the egg that I am talking about, but here we are basically referring to the egg that's going to go through a variety of changes and acquire a bunch of different names and secrete a variety of hormones, and we will go through that, but I just want to orient you first before we continue on. And then here we have our hormones, and our hormones in this case today are going to be estrogen, progesterone, luteinizing hormone, and follicle stimulating hormone. And then finally here at the bottom we have our endometrium. I want to start out by talking about an overview of the menstrual cycle. So in our overview, a normal cycle is going to last around 28 days, and this is largely going to be defined by the luteal phase, which is fixed at 14 days, and the follicular phase, which can vary between 14 days. It can be as short as 12, as big as 17. It's really going to vary from person to person. And then we have menses, which is the classically colloquial term period, where we experience bleeding, and this is going to occur between 3 to 7 days. And then we have 12 months without menstruation. This is going to occur later in life, around age 50, and this is called menopause because we are putting a pause on our menses, and we will be talking about menopause more in future videos, but I just want to cue you into the fact that people are going to be going through menstruation from puberty to approximately menopause, which occurs around age 51. So we're going to talk about the majority of this cycle through the viewpoint of the ovary. So let's go ahead and get started with days 1 through 14, which is going to be our follicular phase, and I'm going to highlight this in green because the follicular phase is largely governed by estrogen. So let's go ahead and zoom in and take a look at what's going on here. So you'll see here that we have this guy, and this is our primordial follicle, and our primordial follicle is actually quite simple. It is just going to be our egg surrounded by a simple squamous epithelium. Now something awesome is going to happen. This simple squamous epithelium is going to go ahead and it is going to gain FSH receptors, and these FSH receptors are going to respond from FSH, which we have hanging out down here, and FSH is going to cause this follicle to mature, and it is going to go through a number of changes. So first it's going to become what we call a primary follicle, and this is also going to have simple squamous epithelium, but it's going to get a special change. It's going to get the addition of cuboidal epithelium, and these cuboidal epithelium we refer to as granulosa cells, and these squamous epithelium we refer to as theca cells. So I'm going to go ahead and write that in for you, theca and granulosa. And our granulosa cells are going to be responsible for producing estrogen, which I'm going to denote as these green dots. So our primary follicle is not very mature, so it's only going to be making a little bit of estrogen. However, our levels of FSH are going to continue spurring this follicle on to get bigger and bigger. So eventually it's going to become a secondary follicle, and secondary follicles are cool because they have multiple levels of cuboidal epithelium. So they have multiple levels of those granulosa cells. So I'm just going to draw a grid here as if we have many cuboidal cells, and so their capacity to make estrogen is going to go up. So we're going to be able to get more estrogen the more cuboidal epithelium that we have. And then we're going to have FSH continue to rise. So FSH is going to spur this follicle on to get bigger and bigger, and it is going to make even more estrogen as it does so. So our estrogen is increasing and increasing here as we keep going. And eventually our goal here is going to get to a structure called a tertiary follicle. And our tertiary follicle is defined by the squamous epithelium on the outside in the form of theca cells, and then our monstrous amount of granulosa cells at this point. And then they're going to have a fluid in the center, and this is called the antrum. And you can appreciate this fluid here that I'm kind of outlining in black. And when the antrum fully envelops our egg here, just like this, that is when we get determined as a tertiary follicle, which is also known as a Graafian follicle. I don't know why it's called graphene, but it's kind of cool. And then we're gonna zoom out now to appreciate a magic moment that I want you guys to appreciate as ovulation. And I have a special mnemonic for the physiology that is happening here. So I'm gonna outline this kind of red area here. And so if you follow where I'm outlining some hormone trends as well as the structures. So what happens here is something that I like to call pop. Okay, and this is going to be important because it's all about positive feedback, which will lead to ovulation, and the whole process is peculiar. And why is it peculiar? Why do test writers care about this important piece of pathophysiology? And it has to do all with the positive feedback, because positive feedback is very rare in biology. Most of all of biology is negative feedback, and negative feedback is, for instance, if you produce a lot of estrogen, it's going to feed back to the pituitary and say, okay, you can stop now with the FSH and LH. That's classic negative feedback. It occurs everywhere throughout the body, whereas positive feedback is very rare. And in the case of positive feedback, if you come into this area that we have bracketed in red, you'll see we have this increase in estrogen, right? With an increase in estrogen, we would expect a decrease in FSH and LH. However, that does not happen. We actually get surges in both FSH and a big surge in LH. And all of this together, this increased estrogen, this increased LH, this increased FSH, is going to lead to the egg popping out of its tertiary follicle and being released. And when it pops out the fallopian tube, the fimbriae are going to be trying to grab it up and create a pregnancy. And so the egg will pop out and it will go into the fallopian tube, and then hopefully it will meet a sperm if that's the goal. So just to review, let's go over our bullet points. We have FSH, which is going to act on our ovarian follicles and cause them to develop. It is our granulosa cells that are producing estrogen. And at first, these have negative feedback, so they're actually going to decrease the FSH, and you can appreciate that dip here down in our FSH when our estrogen was high. However, at one point we're going to experience our POP, which is positive feedback ovulation, and it's peculiar, and it's going to be a big increase in estrogen, which we appreciated here, and then a big increase in FSH and an even larger increase in LH, and that's going to cause the pop, and that egg is going to pop out, and that is ovulation, and then the fimbriae are going to sweep it up, and it may or may not meet a sperm. So let's move on now post ovulation to talk about our luteal phase. I'm going to highlight the luteal phase largely in purple because it is all about progesterone, and I like to highlight progesterone in purple. So after our LH surge, we had ovulation, and then we had rupture of our tertiary follicle. So remember, there was that nice lake of fluid and cuboidal epithelium that was protecting our egg and also producing a lot of estrogen. Well, this is going to change into a structure called the corpus luteum, which I'm highlighting here in purple, and its sole job is to produce progesterone. So it is going to become a progesterone factory, which I'm highlighting with all these big purple dots, and you can see we get this big bump in progesterone at this point. And the job of the progesterone is to promote our endothelium to become a secretory endothelium. So we're going to get things like production of spiral arteries and secretion of important substances that are supposed to support a pregnancy, because progesterone is progestation. That's how I like to remember it. So remember that tertiary follicle is going to become the corpus luteum, and then our progesterone is responsible for production of our spiral arteries and our secretory endothelium. Now let's take a moment to go back to our POP, where our egg came out and went into the fallopian tube, and that is going to be what I'm highlighting in red here. Here is our egg that is ready to be fertilized, and let's say that our egg indeed does meet a sperm. That is going to trigger something really important. Upon fertilization, we are going to undergo a bunch of cell divisions, and we're going to create something called a trophoblast, which has a special population of cells called syncytiotrophoblastic cells. So I'm going to draw those in here because that's what they would look like, and they have the job of producing beta HCG. And beta HCG I like to think of as like the pinch hitter or the cheerleader, and essentially what it's doing is it's going to tell the corpus luteum, hey, you need to continue making progesterone, because the corpus luteum normally it just wants to make progesterone for 14 days, a fixed 14 14 days and then it taps out. So normally our corpus luteum is like, yeah, I'm going to produce progesterone, but then at day 14, I'm going to die. I'm going to fade away. I'm going to regress. However, beta HCG is like, not today, mama. You got to keep working. And so in the case of beta HCG being released from our syncytial trophoblast cells, our corpus luteum will continue to make hormones all the way out until 10 weeks, at which point the placenta will take over hormonal production. So I like to think of beta HCG as the moment for a pinch hitter or a cheerleader to come in and keep the corpus luteum alive. If not, our corpus luteum is going to regress. So we're going to have no fertilization and our corpus luteum will regress, and we will have a big dip in progesterone. And you can appreciate that dip in progesterone as it sinks down here. And this is going to be triggering menses. When we have that big dip in estrogen and progesterone, there is nothing to support that epithelium anymore, and so it will slough off. Now that we've talked about the whole cycle through the viewpoint of the ovary, we can talk about it through the viewpoint of the uterus, which is a lot more simple if you understand all the hormones that were coming from the ovary. So let's talk about our menstrual phase, which is going to be days 1 through 7, and that's going to be when we have bleeding. And this is only going to occur in the absence of fertilization, because remember we said the corpus luteum was like 14 days and I am done unless beta HCG comes around. But beta HCG doesn't come around, then we're going to have the corpus luteum regress and we're going to get that decrease in progesterone, and that is going to cause vasospasm of the spiral arteries and cause bleeding and sloughing of our endometrium. Then once we kind of have that blank slate, we're back to our primordial follicle. Everything is run by estrogen, right? So in days 7 through 14, we had our proliferative phase, which we talked about all here, and this was the growth of our primordial follicle spurred on by FSH. And as it did so, we noticed that it was releasing lots and lots of estrogen here, and that estrogen had a special job. Its job was to make the endometrium grow. So it is all about proliferation. So growth of endometrium via estrogen, and the follicle is what is producing this estrogen, and we're going to get proliferation of our endometrium. So that is why we get so much estrogen during that period. It is all about growing up our endometrium. Finally, we have our secretory phase, and this is normally going to last an exact 14 days unless we have fertilization. Then our pinch hitter beta HCG comes in and does some cheerleading to that corpus luteum. But in normal circumstances, our corpus luteum will produce progesterone, and this is going to cause changes in the endometrium. The progesterone itself is going to prepare the endometrium for a gestation, and we're going to have spiral arteries extending their full length of the endometrium. And you can appreciate all this vascular change in here that we did not have before. And the endometrial glands are going to be described as very tortuous during this period. That's something that you might get asked about on exam day. And then at the end of 14 days, if there's no fertilization, we're going to pop right back to our menstrual phase, because that drop in progesterone is going to lead to the sloughing off of all of that material and a menses. So in terms of a high yield review, I would just really understand the concepts of this diagram. So understanding that everything is going to begin with this primordial follicle, right? This primordial follicle is going to grow up and become a big tertiary follicle. And as it does so, it is releasing estrogen with the hopes of growing this endometrium. Then at the midway point, we have our magic pop moment, which we talked about, which was positive feedback, ovulation, and it's peculiar, right? Positive feedback is very strange, and we get this big pop and our egg comes out. And if we have beta HCG via fertilization at this moment, we are going to extend and have a very long period of progesterone, because the corpus luteum is going to be cheered on by our beta HCG. If fertilization does not occur, we're going to go into a normal secretory phase for 14 days exactly, where we are going to grow in hopes that that fertilization happens. If it does not, we are going to get a big drop in progesterone, which is going to lead to sloughing of our endometrium. So just go over this diagram a few times, draw it out, understand how that egg works and how it changes, and you guys will be set for test day. Can't wait to see you guys in the next video.